Okay, let's do problem 4 in homework 3. The frame ACD, you can see frame ACD is hinged at A and D. There's a hinge here at A and there is a hinge at D. It's supported by a cable that passes through a ring at B. You can see that there is a ring B here, and that's a cable that's attached to this, and then which means that the tension BH and tension BG are the same. Knowing that the tension in the cable is 1125 Newton, the first determine the moment about the diagonal AD of the force exerted on the frame by portion BG of the cable. So this portion BG in the cable, he wants to know this portion BG in the cable, he wants to know the moment around the diagonal AD. For this type of problem, you need to find the moment around the diagonal AD. There is a certain solution. First of all, let's find out the coordinate A. Coordinate A, you can see it here. It's on the z-axis, which means that x is 0, y is 0. Only z is what? You can see it's 600 millimeter. So you could put 0, 0, 600 millimeter. Let's go for D, point D. Point D, it is, you can see it is in the x-axis, so y and z are 0. So x is what? You can see it here, 400 and 400, so it's like all the way, so it's 100, 800, 0, 0. Let's look for G. G, it is, you can see it's on space, and it is on this level, 280 millimeter on the Z. So 200 millimeter on the Z, you can see it. And also in the Y, it's going up. So this up is how much? This up, you can see it's going up, it's 740 millimeter. So 740 millimeter in the Y, and X is 0 because X is in that side and it's not included here. You could find H if you want to. H is in the X, 700 millimeter in the X, and 600 millimeter in the Y. So 700, 600, and 0. And then B here, you can see that there's 400 millimeter in the X, and you can see in the Z, there's 600 millimeter in the Z, and it is in the XZ plane. Y is 0. So B is 400 millimeter and 600 millimeter in the Z. So 400, 0, 600 millimeter. For this type of questions, if you want to find out the force of this portion BG, this cable BG, this portion, on the diagonal, on a line AD, well, if you want to find this moment AD is equal the unit vector AD, dot product, the position vector BA. So we have to find out the unit vector AD. That's the unit vector AD. Dot product. The position vector between B and A. Between B and A. You want to choose, since you want BG, you can choose any point. Choose B. B is the simplest to go from B to A, and A is the starting of the line that you want to take moment around. So B to A, that's the position vector, and then cross multiply by the tension BG, because this is the portion BG that we want to take the moment around that diagonal. Tension BG. Okay. Let's find the tension BG. First of all, we have to find out the vector form of BG, which mean BG mean G minus B. Where is G? G is here. G is here. G is here and B is here. So it is BG, which is G minus B. So 0 minus 400 minus 400, I. 740 minus 0 is 740J, and 280 minus 600 is minus 320K. So this is the vector form of BG. Now we should find the magnitude, which is the square root of this square plus this square plus this square. You'll end up with 900 millimeter. And then to find the vector form of the tension BG, it is, he told you that the tension is 1,125, remember? 1,125, that's the tension of the cable. And you should know that this cable and this cable should have the same tension because there's a ring here at the bottom. So the way we find the tension, again, we put 1,125, this is the magnitude of the tension, times the vector of the tension, the vector form over the magnitude. This vector BG over the magnitude of BG. You'll end up with minus 500I, 925J, minus 400K. Now, we found this. We found the tension BG. Let's find RPA. RPA, it is from B to A. From B to A, you can see from B to A, it's only in the x-axis, so you're not gonna go anywhere, or you could do it. You could do it from B to A. You could do it like this, which is almost 400 millimeter. You could do it if you're gonna go from B to A. You could just do it either B minus A. 400 minus 0 is 400I. 0 minus 0, there's nothing. 600 minus 600, it's 0. So it's only 400 millimeter I, which is equivalent to 0.4 meter I. We'll leave it like that. This is the RBA. At the end, what are we going to do with the equation? Unit vector AD. We have to find unit vector AD, which means, first of all, we're going to put the vector AD at the top, which means DA 800 minus 0, it's 800I. 0 minus 0 and 0 minus 600, minus 600K. This divided by what? By the magnitude, 800 square plus 600 square. This would give you 0.8 I minus 0.6K. Now we find everything. We find this. We find this. We find this. Now, what to do now? You should put it all like this. MAD equal. We should put, first of all, the unit vector AD at the top. 0.8, 0, minus 0.6. 0.8, J is 0. This is minus 0.6. And you should put next RBA, the position vector RBA. What is it? RBA here. 0.4I. 0.4I. Of course, we don't put I. 0.4, 0, 0. Last one, the tension BG, the vector tension BG. We have it here, minus 500 to 925, minus 400. Okay? Now, first thing, we put 0.8. 0.8. And then we put it like this. 0 times this, minus 0 times this. So it's 0. All gone. Next one is the minus for this one. So we put it like this. 0.4 times minus 400. If you put it like this, 0.4 times minus 400. But it is a 0, so you don't need to do it. We'll do the last one, minus 0.6. 0.4 times 925 and minus 0 times, so it's 0.4 times 925. So 0.4 times 925 times minus 0.6, it will give you minus 222 Newton meter. This is the answer for the first part of the question. He wants to find the moment of the portion BG around AD. I did this for the portion of BH around AD. You could just do it using the same method. Try it and do it. Find, first of all, pH. You have to find the pH, find the magnitude, and then you should find the TPH, find the vector, the magnitude, the vector form of pH over the magnitude, and then you should find the lambda. Lambda, we have it here, 0.80 and minus 0.6, AD doesn't change. And then you have the next one is the position factor BA, you have it. And then you have the tension PH. Then you can find at the end minus 100 Newton meter. This is an extra, you could just do it. We have here, we have a cable PJ, and to find the moment around cable AD. And also you could find, I did the second one, also PH around cable, around the diagonal AD. Now let's find the next part of the problem. Determine the perpendicular distance between portion BG of the cable and the diagonal. So this line, this cable, to find the moment around the AD is you need to find the perpendicular distance. And for this you have to do it like that. First of all, the perpendicular distance between portion BG of the cable and the diagonal AD is needed. Let's put the tension BG, the one we just found before, minus 500I, 925J, minus 400K. The perpendicular component of TBG will be the only component that contribute to the moment. Of course, the parallel one is not contributing to the moment. Only the perpendicular component of TBG, because we should do the moment between TBG and the distance perpendicular to it, to line AD or diagonal AD. The parallel component of TBG will be used to find out the perpendicular component. So first of all, we have to find the parallel, and then we're going to find the perpendicular. Let's go find the TBG parallel. It is the unit vector AD times TBG. This is by default. So you could find the parallel, and from this you could find the perpendicular. So lambda AD is 0.8 minus 0.6, 0.8I minus 0.6K. TBG, we know it. So here there is a dot product. So what do we do? 0.8 times this plus minus 0.6 times minus 400. It's minus 160. Okay. Now, we found TBG parallel. Now, TBG total, the vector form, is equal TBG perpendicular plus, in the vector form, plus TBG parallel in the perpendicular, in the vector form. And also, once you find this, you could know that if you want to find TBG perpendicular, it's TBG perpendicular square equal TBG square, the total, minus TBG square parallel. And we know the parallel, TBG parallel, the tension in the BG parallel. So TBG square is 1,125 square minus, and TBG parallel is minus 160, so it's minus 160 square. So this minus this, it will give you 1291225. Oh no, I think there's a mistake here. It's 1240025. So this, if you do the calculation, it's going to be 1240025. And TBG perpendicular, you should find the square root of that. This would give you 1113.56 Newton. Once we find this, this is the tension BG perpendicular. So the moment around the diagonal AD is equal, we found it before, minus 222. So we should make the absolute to make it 222 without the minus, equal TBG perpendicular 1113.56 times the distance, because this is a moment is equal force times distance. So you can find the distance by dividing this over this. It will give you 0.19936 meter. Thank you.